The least common denominator for the first problem is 20 because of the 5, the 4, and the 2. Multiplying each side by 20, we then need to distribute. 20 times p is 20p. 20 divided by 5 is 4. And 4 times 18 is 72. So we have minus 72. 20 divided by 4 is 5. 5 times 1 is 5. So we have minus 5p. On the right-hand side, 20 divided by 2 is 10, and 10 times negative 9 is negative 90. We can add 72 to both sides at the same time as we combine our like terms on the left. That gives us 15p equals negative 18. Dividing both sides by 15, we see that we need to reduce that fraction, and p equals negative 6 over 5, as both of those are divisible by 3. Looking at the second problem, we see that the common denominator will be that 45. 45 divided by 3 is 15, and 15 times 4 is 60b. 45 divided by 3 is 15, and 15 times 11 is 165, so that's minus 165. 45 divided by 5 is 9, and 9 times 9 is 81, so that's minus 81. On the other side, the 45's cancel, so we have negative 206. The negative 165 and negative 81 combine to give us 60b minus 246 equals negative 206. Adding the 246 to each side, we see that 60b is equal to 40. Dividing each side by 60, first we see that those reduce by 10, and then we see that 4 over 6 is really just 2/3, since 4 and 6 are both even numbers. Oops. Negative 120 is already alone on the left, but that negative 5 needs to be distributed in number 3. So we have negative 120 equals negative 30 plus 15a. Adding 30 to each side to reverse subtracting 30, we have negative 90 equals 15a. Dividing both sides by 15, a is equal to negative 6. Again, we need to distribute a negative 5 in number 4. We have negative 69 is equal to negative 6k plus 15 plus 20k. Combining like terms on the right at the same time that we subtract 15 from each side, we see that negative 84 is equal to 14k. Dividing both sides by 14, we see that we're going to need to reduce. Both 84 and 14 are divisible by 2, so we have negative 42 divided by 7. But when we do that, we realize that 42 and 7 are actually also reducible, since 7 times 6 is 42. So if we had found the greatest common factor when we reduced, we would have ended up seeing that k is equal to negative 6. In number 5, we need to start by distributing that negative 6. So 8 minus 6 plus 24r is equal to 3r minus 19. I would choose to subtract 3r from both sides to keep the r's positive, and I would combine like terms with the 8 and the 6, 8 minus 6. So 2 plus 21r is equal to negative 19. Subtracting 2 from each side, 21r is equal to negative 21. Dividing both sides by 21, r is equal to negative 1. In number 6, we distribute that negative 3, so negative 21 minus 3n equals negative 3 plus 15n. I would add the 3n to both sides, either as a separate step or in the same step. I would add this 3 to both sides to move it away from the n's. So you have negative 18 is equal to 18n. Dividing both sides by 18 to isolate the n, n is equal to negative 1. In the next problem, we have distributions both on the left and on the right. When we distribute the negative 6, we have negative 6 minus 30n plus 2. And on the right, we have only to distribute a negative, negative 4n minus 4 plus 7n. Be careful not to distribute to anything that's not in the parentheses. Let's clean up each side. We would have negative 4 minus 30n is equal to 3n minus 4. I would choose to add the 30n to each side to get positive n's. Since I'm moving all the n's towards the right, that means I want to move all the numbers towards the left. Now notice everything on the left is canceling, so I have 0 equals 33n. Very important, you have to put that 0 on that side. You can't just let the side of the equation disappear. We would divide each side by 33, and n is equal to 0. Again, we have double distribution on both sides of the equation. So we have negative 6m minus 48 is equal to negative 4m minus 8, and we do not distribute to the negative 2m. Combining like terms on each side before moving things across the equal sign, the left side doesn't change, but the right side becomes negative 6m minus 8. If you start by adding 6m to both sides, you're going to notice that all of the m's are going to eliminate, and you're going to get negative 48 equals negative 8. Since that is not a true statement, there is no value for m that could possibly make this equation true. So we state that there is no solution to this equation. In the next section, we're solving literal equations. We're getting one variable alone. So since I'm trying to isolate a in this case, I'm going to quickly make my see-do table. I see that a is being multiplied by 3k, and that's everything that's happening on that side. So the only step that I'll need to do is to divide both sides by 3k. So dividing both sides by 3k, I have that a is equal to negative 5 divided by 3k. We're solving for a again in this next problem, but this one has a little bit more going on in the see-do table. I see that a is being multiplied by a negative 4, and then on that side we are subtracting 2k. Reversing both the order and the operation, we're going to add 2k and divide by a negative 4 in order to undo everything that's currently being done to the a. So starting on our to-do list, we're going to add 2k to each side. On the left, that leaves us a negative 4a. On the right, we can see that negative 4 and 2k are not like terms. We can't actually combine them. You can either write them in the order of negative 4 plus 2k, or you can say 2k minus 4. Either order would be acceptable. Next, we're supposed to divide by a negative 4. On the left, we see that negative 4 divided by negative 4 equals 1, since anything divided by itself is 1. So a is equal to, over here, we're going to divide. A positive divided by a negative will always turn out negative, and 2 and 4 reduce to 1/2. So we have negative 1/2 k. Negative 4 divided by negative 4 is going to leave us a positive, because that's a negative divided by a negative. And we know that anything divided by itself equals 1, so that's a positive 1. And the next two problems, we are being asked to solve for x. Again, with the see-do table, we have that first, the x is being multiplied by a negative 8. Once it's been multiplied by a negative 8, we see that 10y is being subtracted also in the numerator. Finally, the denominator tells us to divide by 5. So this problem has 3 steps to get x alone. Reversing both the order and the operation, we're going to multiply by 5, add 10y, and divide by negative 8. So let's follow those steps. When we use parentheses to show that we're doing the entire side, remember the purpose of multiplying by 5 on the right was to remove the division. So we no longer need parentheses on the right. We have negative 10y minus 8x. On the left, we just have 5 times u, or 5u. Next, we're supposed to add 10y, and when we do that, we see that 5u and 10y are not like terms, so they can't actually be combined. So we have 5u plus 10y is equal to negative 8x. Finally, our list says we should divide both sides by negative 8. And we're going to need to remember to divide both of those sections. So negative 8 divided by negative 8 is 1, leaving us with 1x or x. On the left-hand side, we see a positive divided by a negative is going to give us a negative. 5 and 8 cannot be reduced, so we have the fraction 5/8 u. Now 10 and 8, we still have a negative because we have a positive divided by a negative, but 10 and 8 are both even. So reducing those by 2 gives us a fraction of 5/4 y. So we have solved for x. In number 12, we are also asked to solve for x. So looking at the see-do table, the first thing we see happening to x is that we are multiplying by a negative 3. Also on that side, we see that we are subtracting 1. So here, we're going to add 1 and then divide by a negative 3. So adding 1, we see that that's not a like term with 8np because the variables don't match. So all we can do is write 8np plus 1. Then we divide by a negative 3. Now, negative 3 divided by negative 3 is 1x, or just x. We're going to do each of the fractions. A positive divided by a negative is a negative, and 8/3 cannot be reduced. We have 8/3 np. A positive divided by a negative is a negative, and that's just a negative 1/3. In number 13, we have k minus a equals v minus w, and we're asked to solve for a. This might be the most subtle first thing. That negative sign means we are multiplying by negative 1. Remember, when we don't see a coefficient, that coefficient is a 1. And then since the k is positive, we are adding a k on that side. To reverse these things, we're going to subtract k and divide by negative 1. Subtracting k from each side, I can see that that is not a like term with any of the variables over there, so it simply adds on to the list. Dividing by a negative 1, we have negative divided by a negative is a positive. And on the other side, that's simply going to change all the signs. So we're going to have negative v plus w plus k. Now, solving for x here is going to be a little tricky. The see-do table doesn't work out very well when x is in the denominator because you can't isolate x while it's in the denominator. You could use the see-do table to isolate this whole term. You would see that you're adding y, but from here I'm just going to subtract y from each side. Since the see-do table doesn't help me all the way through the problem when x is in the denominator, it's not really worth starting. Now, if something's in the denominator, we know the technique of clearing the fraction. So if we multiply both sides by that denominator, we'll have x times u minus y equals k, since x divided by x cancels out on the other side. Now, you might feel like you should distribute, but there's actually an easier option. If you think about what you would do in the see-do table, you would say x is being multiplied by u minus y, that whole piece. To reverse that, we would have to divide by u minus y. So that's what we're going to do rather than distributing. So that gives us that x is equal to k over u minus y.